Okay, here we go. Lecture Module 10, Systems Analysis and Design. Systems analysis and design is one of the most exciting things you can ever be involved with. But I will tell you, it's not the most exciting to read about. And we'll leave it at that. You know, I'm a bunch older than everyone here, so I've observed what's taken place over the last 20 years, and the world has changed. World's changed in the last year, and we can kind of expect more of the same as we move forward. Please note you are required to read and understand the CISS100.com content on Lecture Module 10. There's a lot of information here that is not in the textbook. Again, the textbook covers systems analysis and design in a single chapter. We will have, in your studies down the road in CISS 210, you will have an entire course on systems analysis and design. And there actually even is a second course, CISS 211. Moving on to the four-year school, you'll probably have another 1 or 2 courses on it. And then you can actually specialize this in a master's or in a PhD. You can actually specialize in just one small area of it. So it really is a big field, both detailed and comprehensive. To understand where we've been, I wrote this, you know, the emergence, rapid evolution of digital communications channel, enhanced and shortened physical and service global supply and value chains through web services, provided for user-generated collective intelligence repositories, and really leveled the business playing field. And this has occurred, and it will continue to occur. So what organizations need? Properly designed information systems. So again, there's a lot of information here on this first page and actually in the submenus. I'm going to reference it, but I'm not going to cover it today. There is a video on it actually, so you can always watch that as well. So let's jump right into the chapter material. So what is an information system? Collection of elements and procedures. Yes, interact, accomplish, goal. Probably the most important thing that we recognize right up front is all the elements that go into an information system. And quite often, people don't think about involving themselves. People are the key component. Back in CISS100.com, in Lecture Module 10, I outlined the 4 business resources: people, money, information, and machines. And the most important piece of that is the people. Granted, we can find people, but can we find and retain good people? There's special skill sets for a database administrator, a system and network administrator. We don't find these people just, you know, walking around the street every day. And then as they grow with our company, as they increase their expertise, both discipline-specific expertise and institutional expertise, knowing about our company, they become even more attractive to our competitors. So it's really important that we actually retain our people. We groom them. We create a culture that they feel comfortable in and that they can grow with. And that's really important. And a lot of companies don't ascribe to that. The companies that do succeed at a very high level. Okay, so I move this slide forward because it is the optimal case in enterprise architecture, a consistently integrated enterprise architecture. Now back again on CISS100.com, I outlined the 3 different levels of integration: the data, the infrastructure, and the business processes. So what are these 3 levels? The data. If an organization, say, uses a single database, say the Oracle database, for everything, it won't have to write conversion routines to integrate with other, say, databases. As an example, an organization, if they have both an Oracle database and an IBM database, they actually have to write the code to integrate the 2. And of course, the Oracle database will evolve, right? Will update and create a disparity. So you now need to rewrite those integration routines, maybe. The IBM DB2 database will update. Again, you have to rewrite those integration constructs, those linkages. It's far better to have that single data construct. And I can illustrate this with another example. Let's recall what we've already covered in our web design, right? Today's web, Web 2.0, is based on minimally a 3-tier architecture. Recall at the core of that was the database. The database is accessed with that middle layer of business logic programming. And then of course at the top is that web server that actually distributes and sends out that HTML documents to the end user. Well, let's look at an example. A customer comes to a website and downloads the manual. Where's that manual located? In the database, right? So from a web perspective, they hit that web server, goes down, the request is for, the manual. That manual is brought up, put into a link or whatever, into the web and sent out to the user. Maybe that user finds an error in the manual, or something wasn't clear, and they contact customer service. Customer service records this, and they pass it on to the technical writers. The technical writers see maybe the error, or maybe they see how they could have written it better, and they make the update, and they store that manual back into that singular database that is being shared across the enterprise, right? It's being used by the internal constituents or stakeholders, but it's also being accessed through the web. So when the very next person comes to the website to download that manual, they get that manual that was just updated by the technical writers 1 second ago. That's adaptive customer service. So an enterprise architecture hopefully is a single perspective. It comes from enterprise resource planning. And again, we're looking at integration at those 3 levels. By the way, the other 2 levels, I spoke about the data, infrastructure, well, that's the network connectivity. And that's largely been solved. Everybody has really moved to that TCP IP protocol stack, the internet architecture. The top level is business processes. And again, we're talking people. That's actually the most difficult integration to take place, people. So I won't cover that right now. So an information system, again, hopefully it's an enterprise architecture used consistently, okay, by all of the users. Many different levels, from executive managers down to operational managers, even non-stakeholders, or stakeholders, maybe customers. I copied this slide down further below because I'm going to address this in terms of planning from a time-based perspective, but also from an uncertainty perspective in terms of information. But I will introduce that now. Again, this is recorded, written on CISS100.com in lecture module 10. Information to be acted on should be complete, accurate, timely, and relevant. And in some cases, we talk about uncertain information because it can't be complete. I sell winter coats. I'll talk about this again later. Do I have any idea what this winter is going to be like? Is it going to be mild? Is it going to be severe? I don't know. There's uncertainty there. So in all cases, we can't have complete information, but for making decisions, we do the best we can. And there are mechanisms to actually mitigate this and help us, assist us with coming up with the best solution. Pardon me. Okay, so the system development lifecycle, the SDLC. And by the way, we're going to see this acronym again, very similar when it comes to programming, the software development lifecycle, SDLC. And the 2 are very closely related. Systems, of course, is larger, encompasses more things, and encompasses the entire system. Now, in most textbooks, you'll see 5 phases to the SDLC: planning, analysis, design, implementation, maintenance. This textbook creates a separate one for acquisition of hardware, things of this nature. In other textbooks, you'll see the acquisition actually in the implementation, which makes sense, actually. If you're going to implement a system, you need to acquire the hardware, and you may not be doing it all at the same time, okay? So it's not like you acquire everything and then slowly piecemeal implement it. Because if you had waited a month or 2 to acquire some of the hardware, you might have gotten better hardware, a better price, more functionality. So I believe acquisition actually should be part of implementation, but for the quiz, you're required to understand the textbook material, so there are 6 phases. An easy way to remember the 5 phases, by the way, when you go on to the 4-year school, you see this again. I don't know if you're a fan or not, but Star Wars, Padme, right? Planning, analysis, design, implementation, maintenance, Padme. I'll say it 3 times, Padme. Hopefully people will not forget that. So when we look at responsibility for system development, it can be in-house or it could be outsourced. And there are many considerations here. One, does the organization have the resources, the expertise to develop in-house? Okay, IBM does, yes, right? Oracle, Amazon. But are you taking people away from their daily duties to do the design, analysis, implementation? Okay? Essentially, implementation is what they'd be doing anyway, but can you take them away from their duties to do the design and analysis? Maybe, maybe not. Smaller organizations may not have the resources. Maybe their people are doing critical things and they can't spare any time, or maybe they just don't have that expertise, at which point you need to do it out of house, okay, externally. So when we look at external development or management of this SDLC, we're outsourcing. And again, straightforward terms, offshore, nearshoring, home sourcing. One of the things that is often underestimated or understood is cultural differences. Okay? Here in the United States, we adhere to deadlines. We're very deadline focused. Say that with a smile on my face. There are penalties for missing deadlines in all avenues, but especially when it comes to contracts, systems like that. If you were contracted to do the service and finish the service by a certain date and you don't, there may be financial penalties. Okay? So again, it depends on how the contracts were written. But what we often don't recognize is cultural differences outside of this country. Again, we Americans, we're kind of driven by deadlines. Not every culture, okay, as they exist in foreign countries, have this same recognition that deadlines are critically important. Oh, I missed a deadline, sorry. You know, you may be left holding the bag for that financial repercussion. The external entity, oops, sorry. Colors, when it comes to website design, okay? Color theory. Me, myself, you know, I could care less what the background is on a particular website. That's not true for every culture. Some cultures have colors reserved just for special occasions, for funerals. And God forbid you use the wrong color when you're trying to attract sales in this country, and you offend them by using some color that's reserved for special recognition. So whenever we're evaluating offshore sourcing, outsourcing, we need to recognize that we don't know everything, essentially. We need to research even further on what the cultural differences are and if they may meet and adapt or fit into the model that we are moving forward with. Okay. The SDLC approaches. There are 2 primary approaches. The waterfall model, where each phase flows into the next, and there's very little backtracking, or the iterative approach that just embraces backtracking. And I'll show you the models here, okay? The waterfall model was developed and works in many other disciplines. I can use the example of building a house, okay, engineering. So if we look at the phases of engineering, you know, for building a house, you know, just as an example, a young couple would say a 3-year-old child, you know, problem analysis. Well, we're paying all this money in rent. It'd be nice if we were putting that money into our future, say our retirement, owning property. So let's purchase property and build a house. Okay, problem analysis. Analysis, and I'm sorry, I should have said problem identification with that last phase. Analysis. Okay, I want a good school district, but I want low taxes, property taxes. So these are the places where we could build a house. Analysis. You know, maybe we're going to stick with 1 child, but I'd like a home office, 3 bedrooms, 2 baths. Okay. Design. Now we contract with an architect who creates the blueprints. The architect finishes the blueprints and passes them on to the contractor. You may never employ or use that architect again. The contractor has what they need, they build the house. Of course, maintenance comes down to the end user over time. Okay, this does not work in systems, information systems. Why? The environment keeps changing, technology keeps changing. Back in 2008, without any advance notice, Apple launched the iPad, and it was a game changer. So you're halfway through your systems analysis and design to develop a new system, and suddenly, here's this new device, iPad, mobile computing. You better accommodate it, right? So if you're in design, you need to go back to the analysis phase, go back to problem identification. Oops, new technology. How are we going to embrace this or support it? Back into analysis. So in the iterative approach, you identify the problem, but problems continually arise. You do some analysis, you maybe go back to the problem analysis. You do some design, you go back to analysis. Do some implementation, you may have to go back to design, maybe back to analysis. Recurrently, repeatedly, you're going over planning, analysis, design, implementation, maintenance, over and over and over, okay? So that is the iterative approach. And there are two things that are necessary components of this iterative approach. Rapid application development and joint application development. Rapid application development is prototyping. Joint application development is involving everyone within the organization in that process. Now, you may receive resistance to drawing in everyone for this project. Why? Consider you're a consultant, okay? So you've been hired to do this. And of course, you're getting an hourly rate, or it could be contract. And of course, vice presidents, I'm just making a generic thing here, they just want it done. They don't care. They don't want to pay you hundreds of dollars an hour for you to go speak with administrative assistants to determine what they need. The vice president feels they know what the administrative assistants need. Okay, well, that creates conflict. Okay? People don't like change. They're resistant to it. You drop a new system on end users, and they're not happy. They'll take more breaks, maybe. They'll spend time speaking ill about it. Okay, many things can go wrong. Whereas if you involve them and incorporate them, you get a better product. So rapid application development. Okay, I just spoke about joint application development. Rapid application development, I develop a prototype and I put it in front of the administrative assistant. What do you think? And they say, well, it doesn't look like the old one. I like the old one, just because that's what they're comfortable with. But this is a prototype. Real easily, I can change the user interface so that it looks like the old system and include the new functionality behind the scenes, the enhanced functionality. At which point we've engaged them, they may become our ally. And this may provide many benefits down the road in terms of training, in terms of maintenance. I'll speak about that in just a minute. So again, two approaches, waterfall or iterative. We must follow the iterative approach. Two necessary components of the iterative approach: rapid application development, joint application development. Okay, so let's look at the particular phases now. Planning, problem identification. This can occur for many factors, okay? A business is no longer as effective or efficient as they once were. There may be new entrants into the marketplace that are selling essentially the same product for less money. Are they able to do this? They have updated the latest and greatest machinery, okay? Problem, okay? I'm using this antiquated, outdated construction machinery. So new threats, new technologies, this is always going to occur, okay? New laws. Laws come down, we're seeing that right now. It's the pandemic. Sarbanes-Oxley was the financial fallout in, say, 2002, which companies were then required to provide more transparency, better reporting, better accounting reporting. We have the Health Information Protection Acts. We're seeing that. Throughout this area, we're seeing more and more of these satellite sites from hospitals. They need to integrate their information, but they need to provide the same privacy and security. Pardon me. Okay, so that's problem identification. Moving on to analysis, okay? What's out there, okay? Now, I've said this several times this semester, that it's our obligation, our duty, to remain abreast of what's taking place out in the marketplace. It's so important as to be written into the Association of Computing Machineries, the ACM's, Code of Ethics and Professional Conduct. It's our obligation as IT professionals to remain abreast. This is particularly important in this phase. A company identifies it has a problem. It's no longer competitive. If you're unaware of what's taking place out in the environment, what's out there, what new technologies, what new business models, consumer preferences, things of this nature, you're starting at ground zero. Your competitors likely, if they're professional and have been meeting their obligations, they're already aware. They're up and running, okay? So they have a head start on you. And in this, this discipline in today's market, time to market is everything, okay? So it is our obligation to remain abreast of what's taking place out in the environment. As we do this, we start to construct a cost-benefit analysis. What are the costs of the new system, okay? And it's not just, and what are the benefits? It's not just the quantitative, the numbers, okay? When it comes to benefits, what are the qualitative factors? Can this new system provide better customer service, allowing me to keep my customers longer down the road in the future? It's been identified that it's more lucrative to retain your customers, long-term value, LTV, rather than having to continually go out and seek new customers, okay? So it's better if I can provide that type of security for them, that comfort, okay? So qualitative factors matter in cost-benefit analysis. So part of the cost-benefit analysis is we'll have decision tables, okay? So we can assess different products, different approaches, diagrams, how does information move around? How is our product created? Both supply chain and value chain, decision trees and other types of models, and ERP models, things of this nature. We'll look at those. It's also very important that we document the instruments used for data gathering. Right? Again, information must be complete, accurate, timely, and relevant. Okay. Is it complete? Well, we asked these questions, but we should have asked these other questions also. So maybe our information was incomplete. And we keep this as institutional knowledge. So again, when we go through these phases, the system development lifecycle again in the future, we know what to do. We get better, continuous improvement. Was the information relevant? Okay, environmental analysis. Well, I charged someone to read up on these resources and they were accessing documents that were 2 and 3 years old. Okay, out of date. Was it relevant? Okay, maybe it was complete and accurate, but maybe it wasn't relevant to today's environment. So if we look at those tools in a little more detail, really just right now we're just looking superficially at them. We're going to look at some of these in more detail down the road. The first is the entity relationship diagram. And recall what I said, at the basis of every information system is that database, that data store. We're going to see entity relationship diagrams again when we get to databases. They are essentially the modeling construct we use to develop database management systems. And it's said, and I'll repeat this when we get to DBMS, if a database management system is designed and implemented correctly, it'll actually reveal the functionality of that organization. So it's a reflexive relationship here. Decision tables and decision trees, okay? Again, we're assessing alternatives. We'll also look at data flow diagrams, how information is processed, who needs it, what are the various entities in the organization that need it, and how is it processed throughout the organization. In class diagrams and use case diagrams, here we're really talking about object-oriented systems. So I'm going to introduce these. However, I'm really going to defer this discussion to the chapter on programming when we'll look at object-oriented systems in further detail. So just two examples, decision tables, okay? Highly effective, again, in cost-benefit analysis, because I'm looking at all these possible paths, all these possible solutions, and I have these end goals because I'm continually also assessing efficiency and effectiveness. And recall, efficiency is a quantitative measure. I can divide the output by the input. I can determine how efficient this process was. But it's not only how efficient the process was, did it meet the goals? That's a measure of effectiveness, okay? So in a decision table, I can put it into a table. These are the important criteria. What is checked off for each different approach, each different solution, etc. Okay? So it allows me to make a decision on which path to pursue. Data flow diagrams show how data moves throughout an organization. And of course, we can easily associate each one of these boxes, of course, with an entity. So hopefully you caught that too, because I just spoke about an entity relationship diagram. So that's what we're really talking about, entities, and how are they related? How is information flow and used by and between the various entities? Now, if we look at an object-oriented approach, we're looking at class diagrams and essentially use case diagrams as well. Now, I know some of you are in programming and logic. I don't know if your faculty have presented this to you, but this should look very familiar. They may not have presented, if you see the right angle there, the 90-degree angle, that indicates a class. What is a class? A class is a blueprint, right? That's all it is. It's a design. In Java, when you define a class, you're creating a blueprint. You create objects from that blueprint. Very similar, you know, the architect, you know, makes a blueprint for a house, right? It's just a design. You could create 1 house, 3 houses, 5 houses based on that design, just building it, okay? Instantiate it, so it becomes an object. When we get to programming, I'll use the example, you know, what color is a Jeep? You can't answer that, you know, the car of the Jeep. You can't answer that. Why? Because that's just the blueprint. It's just Jeep. I can point to an object, say what color is that Jeep, and then you could give me essentially its color, its state. Its state is defined and captured in the attributes. Whereas an object also may have behaviors, and these are represented as methods. So if you're in Programming Logic 1, hopefully this is making sense. Or you see it, better yet, you're seeing the relationship there. Use case diagrams, what can an object do, okay? A customer can place an order, update their information, make a payment, okay? These are the permissible things. And note, it's the customer that updates their information. There's actually an object-oriented design, there's actually built-in security through encapsulation. I'll present that next week in programming. Okay, so we had problem identification, we had analysis, moving into system design. So what will the new system look like? How will it work? Okay, so it's being created, designed from the phase 2 analysis deliverables. Okay. One of the things in the system design that will be created is the data dictionary. And we're going to see this again. The data dictionary defines all the data and describes it in a database. And recall, the database is that core level in any information system. So we're starting to see how it all fits together. Okay, now in the design phase, again, we may have the expertise in-house, we may not, okay? If we don't have the expertise in-house to even come up with a good plan, or maybe we want to see what other people would do in this instance, is submit, put out for bid, a request for a proposal, okay? How would you solve this problem? Okay. Down the road, when we really specify what we're going to do, I may need a new web server, okay? There are a lot of companies selling servers that are appropriate for web servers. I'll send out a request for quotation. And here there's an art there. Experience plays a big part in both RFPs and RFQs because we have to specify as much as we can in the RFP and RFQ. If we don't, we're not comparing what we get back. We're not comparing apples to apples. If we leave anything imprecise, I may get a server that has these specs, and another server that has higher specs. Of course, this one has a lower cost. But how can I actually equate the two? How can I evaluate the two? Because they're different. The only true evaluation comes from similar items. And there are many things. Again, I'll probably create a decision table when the quotes come back, because there may be little differences in terms of their warranty, in terms of their support. So I may want to choose one vendor off of another based on this criteria. Okay. So deliverables from this design phase are all the RFPs and RFQs, all the documentation, and the actual design. What does the system going to look like? Okay. Acquisition. Okay. Now, this book again creates a separate phase for acquisition. Typically, again, most texts, most courses will treat this in the implementation phase, not as a separate phase. But one of the things that you'll have to determine in terms of software is the make or buy decision. And now we're also drawing on our previous coursework in application software. Recall, there are two types of software, categories at least, vertical software and horizontal software. Can I purchase something off the shelf that will work? Okay, maybe. Will it be effective? Well, it checks most of the boxes, but maybe it doesn't get us quite to the goals that we want. So these are some of the decisions you're going to have to make. And are you going to, if you do it in-house, if you create the software in-house, are you pulling people away from other projects that are just as critical? So how's your manpower? So there are a lot of things to consider. Moving on, phase 4, implementation. Well, system is installed, tested, made operational. You have to migrate all your data. There are 4 different approaches in implementation conversion. So what do we have? We have direct conversion, parallel, phased, and pilot. Direct conversion should be your last resort. Direct conversion occurs when you turn the old system off and you turn the new system on. Why would you have to do this? If you cannot afford hardware, and a lot of companies cannot, you have to reuse your old hardware. So Sunday night at midnight, you're installing the new system, you're migrating your data over, you're flipping the switch on the new system for Monday morning, and fingers crossed. Now, maybe you've planned, maybe there are certain times of the year when you have less load on your system. But again, you probably in simulation tested, tested the new system. But again, it's through simulation. Who knows what will happen in the real world? So direct conversion, again, your last resort. Many times it's an organization's only recourse because they don't have money for completely new hardware. Best scenario, parallel conversion. 100% new hardware. You install the new system on the new hardware, you flip the switch, turn the new system on. Should something fail, revert back to the old system. It's still there, right? Parallel. Now, not all companies can afford to do this because again, when the new system works, now you have this old equipment, what are you going to do with it? Okay, yes, you can resell it, pennies on the dollar. Maybe you can repurpose it, who knows? Phased conversion kind of blends. It's not as bad as a direct conversion. It's not as good as a full parallel conversion, okay? So it's implemented by modules, okay? Slowly bring module by module online. Now, this is gonna have a higher cost because the new module that you bring online has to integrate with the old system and has to integrate with the new system. Increased programming, okay? Not only that, maybe because now you have linkages to 2 different systems, maybe you've increased your security vulnerabilities. So there are a lot of things to assess here. Pilot conversions. Pilot conversions work well with organizations that may have a satellite office. It's almost standalone, okay? You know, I used to use the example of banking. And to some extent, it still applies. You know, banking's gone online. So maybe the individual tellers themselves, you know, working in a bank can use the new system. So of course, independent of this is the consumer's perspective of their online banking. But a pilot conversion works, again, where an organization maybe has standalone satellite offices. Now in implementation, pure overhead, one of the most important things is user training. Okay. User training is pure overhead. You're taking your people offline and you're training them, okay? Their experience, their expertise is increasing through the training, and even their institutional expertise, their knowledge about the organization. As such, they become more attractive to your competitors. So not only are you training, you're investing time to train them, you may have to give them a pay raise to keep them with your organization. Returning to the design phase, application and joint application, hopefully you as a consultant were allowed to do this. If so, you're able to interact with the end users from the get-go, for lack of a better word. You may have even become friends. They're invested in you to see that your system succeeds. Let's look at the alternative, the absence of that. You're a consultant, you're coming to develop, a new system for this company. And you're working with the vice presidents. And they don't want you wasting any time working with the end users, the administrative assistants. So you develop this system and you lay it on their desktop, it's complete. And they don't like it, they don't like change. So productivity goes down. And the vice president looks around and they don't know system development lifecycle. They don't know that not performing joint application development and rapid application development really hurts. All they see is productivity went down. And they look for a cause. It's that new information system. So now one of their friends calls them and they said, hey, I know you use these consultants to develop this new system for you. How's it working? And that vice president says, horrible. Productivity's down. It's that damn system. You're not getting hired again, okay? Because you were not allowed to do your job. It's so important that you actually engage with all of the end users. Again, if you're able to work rapid prototyping, put it on the desktop, and they say, oh, I don't like it, doesn't look like the old system. So you redesign the user interface so it looks like the old system. Suddenly they're happy. Suddenly they're your allies. So in training, big room, 30 people training, a few people may get it right away. If they're invested, they help each other. They assist you with the training. Down the road, when a new employee comes online, they train the new employee. Without investing, you bring trainers back to train the new employee. Okay? Again, the iterative approach. It all works together. It has to be done from a holistic, comprehensive perspective. There are times, as a consultant, you come in and speaking with the vice president or the powers that be, they tell you that you cannot engage or interact with the end users. There are times you should walk away, knowing that it's going to be a failed project and it's going to hurt your reputation. So, coming out of the implementation phase, there was a lot of documentation, tons, okay? You wanna record everything. Again, I'm ex-military. And after every operation, we would have, a debriefing, after action reports, things of this nature. And we'd detail everything. We tried to continually add to the institutional knowledge so that we'd be better prepared down the line in the future on the next operation, every time we do it. And it's one of the things, if you're programming in logic, you're probably just programming, you're not really thinking about the documentation. Documentation is so important, but I'll speak more about that next week when we get to programming languages. The last phase is the maintenance phase. It is the most expensive phase. Most people think it would be the implementation phase, right? You're buying all the new hardware, and that's expensive. However, the implementation phase is relatively short. You can be in a maintenance phase for 5 years, even longer, right? Your help desk, paying your help desk employees over time, over the course of 5 years, is expensive, okay? Over time, there are going to be new entrants, new competitors, and they're going to come in with the latest and greatest technology. So they're going to be more efficient, right? So your cost structure may be out of line. You're not making the profits you once were. This too must be added into the maintenance phase. So the maintenance phase is the most expensive. You're continually, hopefully continually making adjustments, improvements, because it's far better to make small improvements over time, continuous improvements, rather than radical business process re-engineering, okay? People don't like change, but people really don't like disruptive change, major changes. Okay. The remainder of the chapter really is a survey of all the different types of information systems. I'm gonna largely leave it up to you to read. I'm not just gonna regurgitate what the chapter says here. Office user productivity support systems. Well, you can think about our academic computing environment, on campus. What do we have? We have computers across the campus with Microsoft Office, with computer-aided design. We have our administrative support personnel, our financial aid, our registrar. We're all using essentially Office and user productivity software. I can look at state governments, okay, or local governments, okay, and there's kind of a consistency of use in Office and user productivity software. Communication systems, okay? Every organization will have them, some more advanced. Of course, we've been thrust, due to the lockdown, pandemic, into this online world, Zoom. We're using Zoom here. And we've recently seen advances in both by Google and Microsoft Office in their video conferencing to try to catch up. Okay, so it happens. So you can imagine the system development lifecycle that was going on behind the scenes in Google and Microsoft when they identified a problem that here's this new entrant, Zoom, that really stole the marketplace. Transaction processing systems. As soon as I say the word transaction, think database. The core functionality of a database, of course, is to store information, but the units of functionality, how that information changes over time, is used as access, is the transaction. And again, I'm going to talk about this in far more detail in the chapter upcoming on database management systems. But we also must recognize databases are the core of all information systems. Again, they're the core of the web architecture, that three-tier architecture. Within transaction processing systems, there are many types of applications or applications. Order entry systems, e-commerce, point of sale, okay, naturally, it's understood. Payroll systems, accounting systems. So I'm not going to say much more about that. I'm now going to return to this slide, which the textbook presents early, but I'm going to add some information. Okay? One of the things I mentioned was how information at different levels, there's a different level of completeness, different level of certainty. There's a temporal component, time-based, to this pyramid as well. Operational decisions, we almost have complete information. Okay? You can look at the store manager. In their day-to-day operations, Monday through Friday, I need 2 salespeople. Weekends, I need 4. They know that, okay? Why? You can look at sales over time, the history of the sales, how many people in the store. It's almost certain information. Middle managers, tactical decisions. Again, I'll use that winter coat example. How many winter coats do I keep in inventory? Well, I have my past sales, yes. And I even have past sales. I can look at, was it a mild winter or severe winter? But does that manager have any idea if this upcoming winter is going to be mild or severe? No. There are models out there, the forecasts. So they're going to leverage this, okay, maybe with a decision support system, okay, maybe provide some guidance to them. So when we look at tactical decisions, we're looking at, it depends on the industry, let's say 3 to 6 months out, okay. Of course, technology is shorter. Other commodities, corn, gas, things like that, it may be a longer period of time. But tactical decisions have some uncertainty, and they're also a little more in the future. Strategic decisions. Again, it depends on the industry, but let's just say 3 to 5 years. Now you have a vice president. Should we even be in the winter coat business, keeping an inventory in our stores? Because we're seeing all these new models come out online where people can take their measurements just using their phone and can actually see how they would look you wearing the garment online. We're seeing that with eyeglasses, right? We're seeing that with a lot of things these days. So strategic decisions, high uncertainty. So they really need that decision support system, those what if analysis, with a lot of information coming in from the environment. So MIS, I already spoke about this. I'll say a bit more on decision support systems, although I'm going to cover this again when we get to artificial intelligence, and not the artificial intelligence in this chapter, but really towards the end of class. Decision support systems, as presented back in application software, allow us to make what-if analysis, okay? At the most basic, I gave the example of you're determining, or looking at car loans. What if? What if I have $2,000 down, $3,000 in a trade-in, and I finance it over 4 years? What if I finance it over 5 years? What are my payments? What if I put $5,000 down? What if, okay? It allows me to evaluate alternatives. Decision support systems operate on this basic mechanism. But quite often they have more inputs, okay? Again, going back to that winter coat, tactical management scenario, maybe the National Oceanographic and Atmospheric Administration data forecasting the winter is being fed into the decision support system. So that manager thinks that likely it's going to be a severe winter. So I'm going to have increased inventory, okay? So there's a lot of things. Decision support systems are based on what-if analysis, but they extend it in many more ways with a lot more external data. Some of which, of course, is going to come in through web services. Okay. I already spoke about an integrated enterprise system, the 3 levels of integration: data, infrastructure, and processes. Just as a definition, electronic data interchange is exactly that. Data is being exchanged between computerized systems, electronic systems. We first saw this, I'll use an example. One of the first areas to use this, car manufacturing, okay? Ford Motor Company needs tires for its cars. Goodyear, Goodrich, all these things. And rather than fax this information across, let's just send it across electronically. The successor, or the evolution of this, is web services, which we spoke about in the chapter on internet. So I spoke about enterprise resource planning. A lot of things here: inventory product management systems, database, okay? Supply chain management, database, but other things. And I'm going to talk about this more down the road too. Warehouse management systems, again, database, inventory. I did just want to introduce just-in-time. Just-in-time came out of post-World War II Japan. Rather than, the Japanese saw a way to enhance efficiency. Rather than have a warehouse full of product, right, and manage that, we're going to manage the supply chain. So we're going to order the product so it arrives at our manufacturing site just when we need it. This is particularly important in technology. As soon as a hard drive is made, a week later, a new hard drive's coming out, eclipsing and rendering that other one to some extent obsolete. May not be obsolete, but it's not optimal anymore. The rest of the chapter, again, intelligent agents, I spoke about this. I used the word user agents back in operating systems. Increasingly, Our mobile devices are doing things on our behalf. And read through AI, okay? I'm going to cover this actually in 2 days at the end of this course, because we really have to look at machine learning. We have to look at expert systems and AI and how that's shaping the future, because it's here. So an expert system is based on, one, a knowledge base, that data, and then the inference engine, which is the thinking, okay? So neural networks also is another type of artificial intelligence. And that's essentially the chapter. So again, there is robotics. One word on robotics. Again, we're going to cover that at the end of the semester. But we are about to observe a robotics revolution, and that's going to be disruptive. You know, we saw the Industrial Revolution and what that drove, what that caused. We have the information revolution, and on the tail end of that, kind of associated with it at the same time, the robotics revolution, which is going to put a lot of people out of work. So again, you're in the right discipline to ensure your continued employment. So that's all I have. Again,